everyone, and welcome to Clean Agile with your instructor, Robert Martin, also known as Uncle Bob. Uncle Bob has been a programmer since 1970. He is the co-founder of CleanCoders.com, which offers video training for software developers, and is the founder of Uncle Bob Consulting LLC, which offers software consulting, training, and skill development services to major corporations worldwide. He's also an author and editor of many books, and he has published dozens of articles in various trade journals and is a regular speaker at international conferences and trade shows. Check out the speaker bio icon on the bottom of your screen to learn more about Uncle Bob. And before we begin class, I'll point out a few of those widgets on your screen that you may find useful. On the right-hand side of your screen, you should see the resources widget. That's where you can download the slides and access the links that you may need for class. And to the right of that, you should see the Q&A widget. This is where you can enter your content-related questions for Uncle Bob to address during our session today. We do also have a group chat feature available. You can type in any comments that you'd like to share with the entire group here to the group chat widget. And if you have any technical trouble today, I first suggest that you refresh your browser. If that does not resolve the problem, type your issue into the chat box or into the Q&A, and I will be happy to help you resolve that concern directly. And I do have to warn you, for those who are subject to regulated status, that the chat feature should not be used, and that the audience may include customers, vendors, or competitors of you or your employer. And if you choose to take advantage of the interactive features available in this training, and we really hope that you will, you are responsible for any information that you choose to share. And with that, I will now hand the floor over to our instructor, Uncle Bob. The floor is yours.
Thanks, Heidi, and welcome everybody to Clean Agile. For the next 3 hours, I am going to lecture you and yell at you and tell you all the things you need to know about Agile and Clean Agile and everything else. I like to run this course in 3 one-hour segments, and they work this way. I will lecture for 50 minutes, 50 minutes. Then I will turn to the Q&A widget. If you have burning questions that you must get the answer to, type them into the Q&A widget, where they will be remembered until I turn to that widget and answer the questions that obtain therein. At about the top of the hour, we will break for 10 minutes, and then we will resume and repeat that 3 times. So, with that out of the way, it's time for Clean Agile. Oh boy. Okay, let's see if I can get my mouse up here. Yep, so this is me yelling at all these kids to get off my grass, right? Because I've been doing this for a very long time. I've been a programmer for well over 50 years. I was at the very beginning of the Agile movement. That was over 20 years ago. What you're going to get here are my personal recollections and observations over those last 20 years. The lectures today are not going to be technical. There will be no code. I'm not going to be talking about anything coding related. So this is for programmers and non-programmers alike. If you've got managers that need to hear this, call them into the room. Get them in here so they can hear it too, because they're all going to need to hear it. This talk is about Agile, the small idea about the small problem of small programming teams doing small things. I know everybody wants to blow it up into some gigantic thing. Oh, Agile, that's how we're going to do 100 million line apps. No, that was never the intent. The intent of Agile was to figure out how the heck you get 6 or 7 or 8 people to work well together. That was kind of it. It was a small idea from the 1950s that we lost in the 1970s because we thought we should be doing big things. And I want to go through with you why this got lost. You see, there was a discontinuity that occurred right around the 1970s. The original programmers, and I'm talking about, going back now into the 40s and 50s and the 1960s, those people were old. They were in their 30s at their youngest. They were more often in their 40s or 50s or even 60s. because there were hardly any computers in the world and there were no courses that you could take to learn how to program them. So the people who learned how to program them were generally much older people who had been around for a long time and could afford the time to sit down and work out how to program these horribly temperamental machines. The knee of the curve happened around 1975-ish. That's my guess. I was actually a programmer at the time. And what we saw was an impossibly young cohort of 20-somethings, myself included, mostly male, pouring into the industry because the universities had finally created computer science curricula. And a lot of people were signing up to it, and a ton of people got into the business. And for good reason. The demand was enormous. The demand for programmers was through the roof, as it is today. Yes, I know we're going through a very brief and very small recession in the technical industry at the moment, but believe me, it's not going to last long, and that demand is going to reassert itself with a vengeance in the next few years. That is the pattern of software development. The demand always outstrips the supply of programmers. Then there was a reawakening, and that reawakening occurred in the 90s. All those young men that were hired in the 70s kind of grew up, and they looked around and said, and I was one of them, and they kind of looked around and said, oh, yeah, we've been screwing this up for the last 20 years. Let's see if we can't work out a better way to work. And that's how Agile began. And we called it Agile, and it changed everything. And what I want to do is go through that history in some detail with you. So now, 20 years on, the idea has been muddled again. Of course, we've got all these adjectives: lean, Kanban, safe, less, modern, skilled. I mean, this comes about because consulting companies need to be able to differentiate themselves from one another, and that means they create adjectives. Now, these adjectives are not necessarily bad ideas, like safe and less and Kanban and lean. All these things, not bad ideas, but they are not part of the original Agile message. They are add-ons. They are bolt-ons. They are somebody's idea to differentiate themselves from somebody else. So today, we're going to take the time to study another reboot of Agile, the small idea about getting small things done. There's some people I need to thank. On the left, you see Kent Beck. On the right, you see Ward Cunningham. That pair, probably more than anybody else, was responsible for the reboot of Agile. There were other people involved, of course, and I'll be talking about them later. But these were the two guys that really kind of pushed it over the edge and made the industry aware that we'd been screwing up royally and that there was a better way. The two of these guys, by the way, worked at Tektronix together. The language they were programming in was Smalltalk, and the platform they were programming in was oscilloscopes. So this was embedded real-time software written in Smalltalk inside laboratory equipment. So fairly interesting environment. Kent Beck, of course, went on to write a book called Extreme Programming. That was in 1999. And that was sort of the event that really pushed Agile into the mainstream. At the same time, we've got Martin Fowler, who was there right at the beginning of the Agile movement and provided a steady hand. The man, you could think of him as the guy in the back of the boat holding on to the tiller, right? Holding on to the rudder, making sure that the ship continued to move in a straight line. When things got raucous or things got crazy, it was Martin Fowler who sat there with that smile on his face and just kind of calmed everybody down and put them back in line and pointed them all in the right direction. Then there's Ken Schwaber. The thing about Ken is indomitable energy. He was an idea factory, constantly pouring out ideas. We could do this, we could do that. We should be able to do this or that or this. And he came up with a number of ideas, some of them even good, that helped us get Agile across the finish line. These are the Poppendicks, Mary and Tom Poppendick, who got involved pretty early on. Mary was the first secretary of the Agile Alliance. Tom is her faithful companion and was the official photographer of the Agile movement back in those days. Lots of energy. They got really involved. They were great to have around. This is Ron Jeffries, the warm and gentle conscience of the early days of Agile. The guy who kept on reminding us that this was about people. Good old Ron. Mike Beadle, who was there at the beginning with us, fought the good fight, and then was killed on the streets of Chicago by a homeless person at 3 a.m. Well, rest in peace, Mike. He was a friend of mine. Many other people that were there at the original Snowbird meeting: Ari Van Bennekom, Alistair Coburn, James Grenning, Jim Highsmith, Andy Hunt, John Kern, Brian Merrick, Steve Meller, Jeff Sutherland, and Dave Thomas, Pragmatic Dave Thomas. More about some of them later. And a special acknowledgement for Jim Newkirk, who was my business partner at the time, who put in tireless effort towards the mission, facing incredible personal headwinds at the time. This is the group at Object Mentor. This is the group that led the original Agile coursework. The people we trained. We did the first training of Agile. We had people packed into rooms. I'll tell you about that later. And this is the crew that brought that into being. And yes, that is the Starship Enterprise behind them. I had that painted on the wall because, I mean, why wouldn't you? And here is the photograph of the Agile Alliance founding. On the left, you've got Mary Poppendick, and then there's Ken Schwaber. And that's your left, not my left. Then I'm in the middle, and then Mike Beadle next to me, and then Jim Highsmith after that. And of course, standing underneath the Starship Enterprise. So, with that out of the way, let us do an introduction to Agile, beginning with its history and how it all began. The culmination was in 2001, Snowbird, Utah, where 17 experts got together to confer about the deplorable state of software. The name of this meeting was the Lightweight Process Summit. That was the subject of the email that went out to invite them all. And it was at this meeting that the name Agile was born, not the concept, but the name. And the idea of the Manifesto was born here as well. But how did this all begin? To talk about the history of Agile, we have to go back in time a very, very long way. Let's see, I'm pushing the button. What happened there? Why did we get a break? I did not want a break. I hit a button, and that button must not have been the right button. So let me go back here. Oh, heavens. Oh. I see. The breaks were positioned incorrectly in the stream. Let's see. In the beginning. There we are. Okay. Sorry about that. We had a little technical snafu. No big deal. In the beginning, 50,000 years ago, the idea of choosing small intermediate goals and measuring the progress after each is just too intuitive and too human to be considered any kind of revolution. And that, of course, is what Agile is. And why did I go back 50,000 years? Well, that is often considered to be the time when human language actually came into being, although there's a fair bit of debate about that. But in any case, if we were to go back 50,000 years and observe human beings in their daily activities, we would very likely see the hint of agile development in process. How do you make a spear? How do you make an axe? How do you make these things? Well, probably a lot of intermediate goals and measuring progress after each. In modern industry, it's hard to say when this began. In fact, it probably didn't begin. It probably just was always there. But you can imagine, right? The first steam engine did not function the very first time somebody put one together, right? They probably had to tinker it and tinker it and tinker it until they finally got something working using what we would consider to be an agile approach. The first mill, the first internal combustion engine, we actually know a fair bit about how airplanes were constructed. And if you just look at the Wright brothers and the way they got those airplanes to work in the early 1900s, they iterated like crazy. They would put something together and try it, and and then they'd go back to the workshop and try something else, go back to the workshop and try something else with a whole bunch of little experiments before they ever climbed into one and actually got it off the ground. Probably all of these were produced by techniques that we would now call agile. Taking small measured steps is just too natural and human for it to have happened any other way. Craig Larman and Bas Vode wrote a book, about 18 years ago, and they went through this history. And it's a fascinating history. If you can get this book, it's a good book to get. Good for managers, good for regular people to understand why we think this way and what the historical basis of thinking this way, where that all came from. So consider Alan Turing. Now, I don't know if any of you guys have read Alan Turing's paper. It's a remarkable paper, by the way. The paper he wrote in 1936. Let's see. What is the name of that paper? It's called On Computable Numbers and Their Application to the Entscheidungsproblem. That's the name of the paper. And in that paper, he invented the Turing machine, and he used that to prove that there were numbers that could not be computed. And by the way, that was in pursuant to a mathematical challenge by David Hilbert, which you don't need to know about right now, but does come in very, very important in the history of computers and the history of mathematics. Now, Alan Turing, in that paper, wrote a ton of code. It's really kind of cool code, too. It's all finite state machine stuff. Very cool code. I cannot believe he wrote it without modifying it. I'm sure that he had to iterate over it over and over and over again. We do know something about the development process on the space program, in particular, the Mercury space capsule avionics software. Those guys wrote their unit tests in the morning and made them pass in the afternoon. So there was a little bit of test-driven development really, really early on. Then there's the IBM Federal Systems Division that did the software for things like the Minuteman missile system in the 60s and the Polaris submarine. And those guys had a process that had a 6-week iteration cycle. That would be long in comparison to an agile iteration cycle. We like to do things in 1 week in an agile cycle. But it was still a cyclic approach, a cyclic tinkering iterative approach. And in the end, agile is the process that is observed amongst programmers in the wild. So if you see a bunch of programmers who never studied anything and just kind of cobbled together their skill out of nothing, they're probably using something like an agile approach. But this iterative cyclic mechanism of development, which we now call agile, was not the only game in town. There was another approach. That approach eventually got the name scientific management. And it's associated with this fellow, Frederick Winslow Taylor, who kind of codified the idea and sold it to the industry. This is the first management consultant. And he created companies that spanned the globe, made a fortune, of course, and he would talk to all of the companies that were just starting out in the Industrial Revolution, and he would teach them the principles of scientific management. Those principles were very simply making a plan and following the plan, using scientific principles to make the plan and follow the plan. Now, this idea is as old as the pyramids in Stonehenge, because it's completely impossible to believe that the pyramids were tinkered together. The pyramids were not an iterative approach, or at least each individual pyramid was not an iterative approach. Now, turns out that if you go to Egypt and you look, you can see that there was a fair bit of iteration going on, because each pharaoh wanted a bigger pyramid than the one before him. So they iterated their way up to really big pyramids, but each individual pyramid had to be planned in advance and executed. That was the idea behind scientific management. And obviously, this is an old human technique, because the idea of repeating a successful process is just too intuitive and human to be considered some kind of revolution. So we see that there are these two approaches, both of them deeply human, both of them intuitive, both of them something that any group of humans would come up with when faced with problems of a certain kind. And that is where software comes in, right at that inflection point in the 1970s, when the demand started going through the roof and the supply of young men poured into the industry. That was exactly the time when we faced the issue, the crossroads of the 1970s, where we had to decide which of these two approaches should we use. And at that point, the iterative approach was already well entrenched. The IBM Federal Systems Division was using it. The space program was using it. Everyone was doing something agile-like around then. But there was a change. The dilemma, the thing that caused the change, was this. What kind of project is best for Agile, I say pre-Agile on the slide, but nowadays we call it Agile. What kind of project is best to iterate, and what kind of project is best to plan? And the answer to that is fairly obvious. Agile projects, iterative projects, work best because they have a low cost of change, and their definition is not complete. They are partially defined. If you have a medium, a development medium that has a low cost of change, and your requirements are not particularly well defined, well, then Agile is great. That's the best way to go, because you can iterate your way both to a good solution and better defined requirements. On the other hand, if you have a development medium where the cost of change is very high and you have very well-defined requirements, you should use scientific management. You should plan it out and you should execute the plan. And the question in the 1970s was, which of these two is software? And the answer to that was not particularly obvious. Nowadays, it's very obvious. I mean, the cost of change to software is impossibly low. We can make change to code very, very quickly, right? And requirements, well, we all know requirements are kind of loosey-goosey all the time, right? So nowadays, Agile is the obvious choice. But in the 70s, that wasn't the case. And why wasn't it the case? Well, let me show you what it was like to work back then. And by the way, this is one of the people who was working that way. That's me at age 18. I was already a programmer, hired at a company called ASC, working on a lot of different things, Fortran, COBOL, a bunch of other things, and eventually on mini computers, working in assembly language. How did we work? Well, this is how we worked. Of course, it was all on punch cards. So we programmed by punching our programs onto cards, but I actually did not say that correctly. We did not punch our programs onto cards. We wrote our programs on, see that green and white piece of paper down there, that's called a coding form. And we would sit at our desk with a pencil and we would write our code in all capital letters within the squares of that coding form. And we would write the code. It would probably take us 5 or 10 or 15 sheets of paper like that, because in those days, programs were not large. And then we would hand those sheets of paper to a group of people called key punch operators. And the key punch operators used that machine that you see down at the lower left. That's a key punch. And they would they would punch in our code and produce the punched cards that you see at the upper left. And by the way, how long would it take them to punch those cards? A day or two. They had a lot of work to do. Everything that went into the computer went in by punch card. So there was a ton of things these people were punching. And anytime a programmer walked into the room to give them a program to punch, they'd all roll their eyes and go, oh God, more work from these idiots in the back room. So it would take a day or two, and then you would get your deck of cards. And you would take your deck of cards back to your desk, and you would thumb through that deck. If you look on that image of the card at the upper left, you will see at the very top, the code on that card is printed in dot matrix form right at the top of the card. And so you would thumb through the deck one card at a time, reading the code to make sure the code was what was on the coding form. And of course, it never was, because the key punch operators were not programmers. They did not know what they were typing, so they always made mistakes. And we had a key punch machine in our room, and we could take the individual wrong cards out and fix them. You fix them by copying them up to the point of the error and then retyping the rest of them. And then we would put the repaired cards into the deck, and we'd thumb through the deck until we were sure that it was ready. And then we would take our deck down the hall to the computer room, where you were not allowed into the computer room. Programmers were not allowed to go in, right? You had to back away from the door. You put your deck in a little basket. Your deck of cards went into a little basket. And then you would back away from the door, and the operator would peer through a window and look at you suspiciously, and then open the locked door and take your deck into the bowels of the computer room. Programmers were not allowed to touch the computer. Only the operators could touch the computer. Up at the upper right, you see a picture of a computer like that and one of the operators operating the machine. Your deck would sit there for many hours, probably until 3 in the morning when all the batch jobs were done, because these machines were multi-million-dollar machines and they had to be kept operating 24/7. There was real work to be done. There was inventory, there was payroll, there was general ledger. There was just a ton of work that had to be done. And all of that work had to be done before they could even consider running a compile through that machine. So around 3 in the morning, the third shift operators would take all the programmers' decks and stick them in the card reader, and they'd hit the read button and they'd go down and get a cup of coffee. They'd come back an hour later and tear off all the compiled listings from the printer, put them all out on a table. You'd come back the next day, 8 o'clock in the morning or so, and there would be your listing with your deck, and you'd take it back to your desk, and you'd thumb through the listing and realize that you had forgotten a comma. That was the way software was done in those days. Even into the early 1970s, software was done that way. And so the cost of change was high. This was the problem. This is why we could not remain doing Agile. The cost of change was high. We needed a better approach. And what was that better approach? 1970, Winston Royce publishes a paper, Managing the Development of Large Software Systems. And in that paper, he drew this diagram. And that diagram looks like water flowing down rocks. And so it was called the waterfall process. And you can look at it and you can see, okay, we've got to get the requirements first, and then we analyze the requirements, and then we turn that into a program design, and then we code the program design, and then we test it, and finally we can operate. That was the waterfall model. And when this diagram showed up on Winston Royce's paper, the world went crazy. It was like, oh my God, of course, we should have known this all along. Yes, this is the way we're going to have to work from now on. We're going to work in these phases. This story is quite a bit more ironic than I've let on, but I'll get to that irony in just a moment. Because now we've entered the waterfall era, and it dominated us for close to 30 years. From the early 1970s until the very late 1990s, it dominated us. And I say down at the bottom that it didn't work, and that's not really fair. It worked, just didn't work great. And as computers got faster and faster and more capacious and more powerful, the cost of change began to shrink. We could get changes done in less than a day. Eventually, we could get changes done in less than half a day. And eventually, we could get changes done in less than an hour, but the waterfall model continued to dominate us. And we wound up with 30 years that culminated in failure. It was not 30 years of failure. Once again, the slide is maybe a little unfair. There were a lot of projects that succeeded just fine, right? But they didn't succeed the way we wanted them to. And as time went on, they got worse and worse and worse. We tried and we tried, especially as the years rolled into the 80s and the 90s. We tried and tried, and we found that this technique was failing, but we could not conceive of why it was failing. So we thought we just had to try harder and do even more waterfall over and over again. How we tried. The level of indoctrination was very, very high. We had decided that waterfall was composed of three elements: analysis, design, and coding. That was the three major phases: analysis, design, and coding. And because of those three major phases, we split everything up by those phases. So when structured programming came along, we very quickly had to have structured analysis and structured design. And when object-oriented programming came along, we very quickly had to have object-oriented analysis and object-oriented design. I mean, my God, how could you not have these things? We could not conceive of another way of working until one day we could. And this happened in the late 80s and the early 90s. There was hints of it in the Smalltalk community at Xerox PARC Labs. They kind of broke the mold. They were working in Smalltalk, working in small iterations. They had gotten the cost of change down fairly low. By 1991, Grady Booch had written this book, Object-Oriented Analysis and Design. Actually, it was Object-Oriented Design with Applications. It was the second edition where he stuck the analysis in. But in that book, he started talking about the necessary rhythm of software, the iterative approach. Although his iterations were fairly long, he did talk about it. He also coined the term continuous integration in that book. Alistair Coburn started writing about methods. He studied a bunch of teams and saw how they executed, and he came up with this theory of processes, which he arranged into a crystal form, a square grid. And one of those processes he called crystal clear, which was a very simple iterative approach. By 1995-ish, 94-ish, 95-ish, the design patterns community had formed. And you may remember the design patterns book. It's sometimes called the Goff book, the Gang of Four book. And great book, by the way, great ideas coming out of the design patterns community. But one of the ideas coming out of the patterns community was this idea of iterative development. Jim Copleen wrote a paper in 1994 that was delivered at the Patterns conference that we all went to in those days. And in that paper, he talked about the power of iterative design. The Scrum paper, the very first paper on Scrum, written by Ken Schwaber, Mike Beadle, and Martine DeVoe, was presented at the PLOP conference, the Patterns Conference, in 1995. So there was something stirring in the mid-90s. The process was beginning to reverse. And this is where I enter the story again. At this point in my career, I am a C++ consultant. I travel the world and I yell at people and tell them they're doing it wrong. And I tell them about C++ and I consult with them on object-oriented design. I'm considered some kind of an expert on the topic. And my clients, although they loved the consulting I was doing for them, always had another question, a question that I was very reluctant to answer. And the question was, what process should we use? And I couldn't answer it. So I started to do some research at home. And this was before there was a Google, before there was a search engine. I honestly don't know how I found Ward's wiki, the very first wiki ever. But I did. I found it somehow or another. And on the pages of that wiki, I bumped into the ideas of extreme programming. Kent Beck was describing extreme programming on Ward Cunningham's wiki. You can still go to that wiki, by the way, c2.com. Yep, the letter C, the digit 2.com. You can go there. That's the very first online wiki, and the wiki in which design patterns and Agile were conceived. As I read through Kent Beck's documents, I thought, yeah, I like this. I like this a lot. Iterative development, short cycles. This is really good, except for this test first thing. I don't like the test first thing, but everything else I think is really cool. And then by sheer coincidence, in 1999, I am at a conference in Munich. It's called the OOP conference. I believe it's still running. Every February, I think in Munich, they have the OOP conference. And I was there, I was speaking, I was doing some classes. And I walked out of my classroom at one point on a break, and there was Kent Beck. He was teaching in the classroom across from me. And I had known Kent Beck from the Patterns community. And so I said to Kent, hey, Kent, we should get together because I'm the editor of the C++ report, and I want to hear about this extreme programming stuff you're doing because I want to publish an article in the C++ report about it. So we went down to the cafeteria at lunchtime, and he regaled me with stories about extreme programming, and I thought, yeah, this is great. Please write me an article. And he did. He wrote me an article, which we published in the C++ report. This is back when, there were actually print magazines. And rave reviews. Everybody loved the article. And as I recovered from that particular incident, I thought, Kent Beck and I should get together and start teaching classes. So I called up Kent, and I went out to Medford, Oregon, and I spent a couple of days with him out there. And we planned out how to teach an extreme programming course. We called it the Extreme Programming Immersion. And we actually ran quite a few of these from 1999 until late 2001. We were running these courses. We'd get 60, 70 people in a room, and the course would last from 9 in the morning till 9 at night. We'd bring in guest speakers. We had Tom DeMarco come into one of them. I mean, it was a big gala affair. We'd do these things 4 times a year, and we'd bring tons of people in. It was a great, great business thing and a great teaching thing. And we were teaching all of this stuff. Sometime around 2000, Kent said, hey, we need to consolidate this extreme programming stuff. We need to have a plan. So he called a meeting called the XP Leadership. And we all flew out to Medford, Oregon again. This is like 2000, early 2000, probably late summer of 2000. And we did the normal thing, we're hiking through the woods, we're taking boat trips, we sit in rooms and we talk with each other for a while. And at one meeting like that, somebody said, maybe we should form a nonprofit organization to advocate for extreme programming. And the room went sour. The people in the room didn't want to do that. And mostly because they had done that with the patterns group and they didn't want to repeat it because they had a bad taste in their mouth. But I disagreed with them. I said, no, I definitely want to do this. And I said so at the meeting. I left that meeting, and Martin Fowler followed me out and said, I think you're right, Bob. We do need to do this. Let's meet in Chicago. So Martin and I met in Chicago a few weeks later, and we composed an invitation to the Lightweight Process Summit. And we sent it out to 20 or 30 people. I don't have the invitation list anymore, but we sent it out to a whole bunch of people. And Alistair Coburn was on that list of people. And he called me like within an hour or two, or maybe it was the next day, I can't remember. And he said, I was just about to send the same letter out. I was just about to do the same idea. You beat me to it. And I like your invitation list better than mine, but I do want to add some people to it. And tell you what, if you let me add these people to the list, I will do all the legwork to set up the venue in Salt Lake City. And what the heck, I'm not going to say no to free labor. So off he went. He set the whole thing up at Snowbird in Salt Lake City, and the Lightweight Process Summit was convened. In the end, I think it was over 30 people who were invited. Of those 30, 17 showed up. And we've been criticized because the 17 who showed up were all middle-aged white men. And that's fair. It's a fair criticism, although it's not as fair as you might think, because the actual invitation list was not all middle-aged white men, but the only people who showed up. And there's a reason for that. In 2000, who were the consultants? They were all middle-aged white men for the most part. So those are the people who showed up. And although maybe there was a lack of diversity in that demographic, there was plenty of diversity amongst the viewpoints, because we had people from the extreme programming camp, from the Scrum camp, from the feature-driven development camp, the DSDM camp over in Europe. Alistair was there representing his Crystal. The pragmatic programmers were there. Andy Hunt and Dave Thomas were there. And they were agnostic. They said, we don't like processes at all. And Martin Fowler was there. He was also agnostic, although he leaned towards the extreme programming side. And then there was Steve Meller. And Steve Meller was the scientific management guy. He was the waterfall dude. And when he stood up to say hello, he said, I am the spy in your midst. Now, this meeting, it went on like any meeting would. I kicked it off with a call for a manifesto. I said, hey, guys, we need a manifesto. And I sat down. And I don't know why I used the word manifesto. I used it because I liked the word for some reason. I had recently read the Manifesto for Object-Oriented Databases, and I thought, gee, what a cool word. And so, fine. And I sat down, and I think that was my last major contribution to that meeting. We did all the things that you would normally do at a meeting like this. We got index cards out. We wrote concepts on index cards. We threw them all on the floor. We did affinity shuffling with them. We wrote things on the whiteboard, bumbling back and forth this way and that. And that's really typical of meetings. I've been to a lot of meetings like that, very typical. And usually nothing happens. I mean, usually it's fun. We get together, some ideas. We all go home and think, okay, well, that was fun. That's not what happened this time. The magic happened on, most of us think it was the second day. I think it might have been the end of the first day, but most people think it was the second day that the magic happened. And what was the magic? Someone went to the whiteboard. No one knows exactly who. And some people think it was Martin Fowler. Some people think it was Ward Cunningham. They began to write the beginnings of the manifesto. It didn't come out right away like this. It was you know substantially different. But the most important part of what they wrote was the word over. Now, if you look at the manifesto, it's in front of you now. Individuals and interactions over processes and tools, not instead of processes and tools, just over processes and tools. And the tagline at the bottom appeared very rapidly before most of this was done. The tagline says, that is, while there is value in the items on the right, we value the items on the left more. This was a watershed moment because once we saw that construction, everything else just fell into place. Ward Cunningham came up with the preamble there. We are uncovering better ways of developing software by doing it and helping others do it. And through this work, we have come to value. And then the four little stanzas there were in negotiation. We all pitched in and talked about, well, made this and that and this and that. And the four that came out: individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, and responding to change over following a plan. All of those came out within 45 minutes. The whole thing was done, 45 minutes. And when it was done, we all kind of stared at the whiteboard, and there was this collective sigh in the room. And we all looked around at each other and realized that we were done, and that the reason we came here was to write that on the whiteboard. That was it. We knew we were done, and it was like, oh my goodness, something actually happened here. Now, then Ward Cunningham had this brilliant idea. And you have to remember the year now is like 2000, right? It's February of 2000. And Ward Cunningham says, I'm going to put this on a website, and I'm going to let people sign the website. Now, in the year 2000, the idea of users of a website being able to modify that website was almost unheard of. Most websites were static in those days. But Ward's put together a little Perl script and put it up on his website so that people could sign it. We all went home thinking, okay, well, this was great, and Ward's going to put it on a website. That's great. And now we can get back to business. And tens of thousands of people signed it. We had no idea. We really had no idea that it was going to be so wildly popular. But yeah, tens of thousands of people signed it, and all of a sudden we had a tiger by the tail and didn't know what to do with that tiger. A bunch of us collaborated over the next 2 weeks to write up some principles that we added onto the website. You can still see them there. But the major thing was done, and we were all done with it, and that was fine. There was no repeat. We did not get together again to do anything important. There was a meeting of a subset of the group a year later at the UPSLA conference in Portland, I think it was, where that group, I wasn't part of that group, and a bunch of other people weren't, but they had enough. That group decided that we were just open sourcing the whole thing. We're walking away. We're not going to be the ones to govern it. We're not going to be the ones to tell everybody what to do or not to do. That's over. It's just open source. And that group has never met again. The group of attendees were called together in 2015, I think it was, I think it was the 15-year anniversary. And it was in Florida at an Agile conference. Although we didn't meet, we were put on stage and we did a panel discussion and answered some questions, but we didn't meet at all. And then there was another one like that in 2020 during COVID. So it was all done by Zoom. And a few of us were there for that, but most were not. And that group is never going to get together again. There's no reason to get us together again. It was a one-time thing. It worked. It was great. And that is how the Agile Manifesto came to be born and why the Agile movement began. Now, it is 10 minutes before the top of the hour, and as promised, I am going to turn to the Q&A widget and answer the questions that obtain therein. If you have burning questions, type them into the Q&A widget. There is one there right now, and I'm going to answer that one. And if you type some in before I'm done, I might answer them as well. VD asks, can you convince Ward Cunningham to give the public permission to use the few photos he took from the Lightweight Process Summit? He rejects any requests from educational institution consultants, agile coaches, etc. In fact, he has rejected my requests for that very purpose, and I can't really fault him, right? Because if he lets them out of his control, he doesn't know how they will be used. And so he has kept those photos, and they are his, and he can do with them as he pleases. And no, I cannot convince Ward Cunningham to release those photos. One of the reasons why, if you look at the photo of the meeting, let's see if I can get that up on the screen again. Let's see, where is that picture? I know I've got it here somewhere. It's on one of the slides. There it is. It's not a very good rendition, so it doesn't quite make the point I wanted to make. You can see Martin Fowler there. It's very clearly Martin Fowler is recognizable because of that bald head and black hair, and beard. It's clearly Martin Fowler. But who's this guy here? See that head right there? Who is that? Well, nobody knows. Who's this guy right there? His head is not there. And if you go to the Agile Alliance website, if you go to agilemanifesto.org, the whole picture is there. And you'll see there's a bunch of us standing around the board with Martin Fowler pointing at the board. And I know it was Ward who took this picture, but it's very difficult to recognize anyone else. If that picture was released in its full detail, you would be able to recognize who these people were. And for some reason, Ward doesn't want to allow that to happen, and that's fine. You know, that's the way he wants to work it. That's fine with me. FN asks, 20 years later, is there anything you would add to the Agile Manifesto today? I actually tried to add something to it in 2006, I think it was, because I was at the Agile conference and I said, yeah, we missed one. It should be craftsmanship over crap. But no, we didn't add that to the Agile Alliance. There's no way to add anything to the manifesto. The manifesto is a signpost in time. It is not a living document. It's not something we modify or alter. It is a moment in time, a snapshot of a moment in time, and it will persist that way. Anybody wants to make changes, well, you're not going to be able to make changes to that particular document, but you can do anything you want, right? I mean, if you've got a better idea, just give it a different name. Call it Lean Agile, call it Less Agile, call it Safe Agile, call it anything you want and add whatever things you want to it and take away whatever things you want from it. But Agile are those four statements. And with that, there are no more questions on the Q&A widget, so we are going to take a break, and that break is going to be 10 minutes long. So I'm going to put a 10-minute break up, and we will resume in 10 minutes, everybody. 10 minutes. And we're back. So begins the Agile overview. All right, I've given you the history, you know how it all came into being. Now the question, what is it? And the answer I'm going to give you comes from a talk that I have been giving for the last 20 some odd years. The Agile overview. I have gone to hundreds of different places and given this hundreds of different times, from conferences to companies all over the world. This is the original Agile overview talk. How do you manage a software project? There's a bunch of options. You see a few of them on the screen. It's easy to do it badly. Lots and lots of people use that technique. Hope and prayer is very common. And you know that this is the technique in place. If you go into the manager's office and you see the two parallel groove lines where he kneels every day and prays to whatever God he believes in, that this project might actually get done on time, under budget, within budget. Not a very effective technique, but pretty common. The last one, dictate and motivate. This one is very common. We tell everybody all the awful things that are going to happen to them if they don't meet the deadline. And then we hang pictures of people climbing rocks and seagulls flying over the ocean. And somehow that's going to get the project done on time. Why do we face this dilemma? Why is it so difficult to manage a software project? Well, first of all, the problems are enormous. If you mismanage a project, a lot of bad things can happen. For example, you can produce the wrong product. Now, I imagine that some of you out there have had this experience. There are some 70 of you listening at the moment, and among those 70, some of you have worked for 6 months, delivered the product to the customer, and had the customer look at you sideways and say, what the hell is this? Yes, it's what we asked for 6 months ago, but man, things have changed. Haven't you been keeping up? Or you could work for 6 months and produce a product of inferior quality. Some of you out there may have done this. Work for a really long time and deliver a steaming pile of crap to the customer. Or you might work for a really long time, but you work and you're late. How many of you out there have been late? It's in some ways the normal state for software developers to be late. We're software people, of course we're late. And because we're late, we tend to work lots of overtime. I don't know about you, but I have worked in the past at companies where we put in 50, 60, 70, 80 hours a week on projects that were late. All of these, by the way, are the result of mismanagement. None of them are the developer's fault. This is all a management issue. And why? Why do we have this effect? And the answer to that is actually fairly straightforward. What we've got here is the iron cross of project management. Good, fast, cheap, done. Pick any three you want. You're not going to get the fourth one. The project, it can be good, fast, and cheap, but it won't be done. Or it can be done cheap and fast, but it won't be any good. That's the law. This is the law of physics, project physics. Choose any three you want. You're not going to get the fourth one. Or rather, if you demand all of them 100%, you can get three of them at 100%, and the other one's going to be 0. That's the way that works. And so, the real challenge to managing a software project, aside from all the people issues, is to find the settings on those knobs, to find the right coefficients. How good, how cheap, how fast, how done. If we can control those knobs, if we can adjust those knobs, then we can drive the project to the best possible outcome. the best possible outcome may not be the original desired outcome. It might be something completely different over time. The needs of the customer change. But if we have control over those knobs, we can drive the project to the best possible outcome. But to do that, we need data. Wouldn't this be great if there were a chart on the wall that got updated every week, and that chart showed you how much got done that week? Now, you look at this chart and it says story points over to the left. What are these story points? I don't know. Don't worry about it. Just some measure of how much got done. But you look at that chart and think, well, I mean, they got 45 points done the first week, and they got 42 points done the next week, looks like. And gee, 50 points the week after that. And okay, I look at that graph and it looks to me like every week they're getting around 43 points done. I expect that next week they're going to get something around 43 points done. Over the next 10 weeks, I think they're going to get 430 points done. This is interesting from a manager's point of view, because the manager can look at that and make predictions based on it, if the data is reliable. If the data is reliable, a manager can look at that chart and make predictions. But there's another chart. This is called a burn down chart, and it shows how many points remain until the completion of the next major deliverable. Maybe it's the next release, maybe it's the next shareholder meeting, whatever it is. It's the next major deliverable. And it shows the number of points that remain to be completed. And if you look at it carefully, you'll realize that it has a slope, and that slope looks like it's predicting a date somewhere out in May. Now, that's useful. I mean, anybody can go into the room, look at that wall chart and think, gee, looks like they're going to be done around May. That might be good news, because maybe they're supposed to be done in June. Or it might be bad news. Maybe they're supposed to be done in April. But the chart isn't going to lie. The chart is going to tell you about when you're going to be done. Now, look at that chart, and you'll notice that there's a funny thing that happened in February of 2003. How is it that you could work for a week and wind up with more to do? Well, there's a couple of ways that can happen. First way that could happen is that the customers called up and added a new feature. That never happens, right? Customers never change their mind. They don't ever add new features or change old features, right? Yeah, they do. They do that all the time. And when that happens, of course, we have to readjust the schedule. And so, okay, yeah, that might happen. You might get a week where that graph actually goes up instead of down. There's another way it can happen, though. The other way it can happen is for the developers to have finished 4 weeks worth of work, and then they go and think, we need to reconsider some of those estimates we did before. And they re-estimate everything, and oh yeah, it's going to take a little longer than we thought, and they add that to the graph. Either of those two effects we want to show. We want this on the chart. We want these two charts on the wall. If we have these two charts on the wall, then anybody can go into that room and they can say, these guys are getting about 42 points a week done. Gee, looks like it'll be May. They can make that determination within seconds. And everybody can then leave the room and go, okay, well, we know the status of this project. What you are looking at is the management information produced by Agile. It is one of the primary outputs of the Agile process. It is one of the primary motivations for using the Agile process. When you use the Agile process, you can produce these charts. A lot of people don't, but they should. Those two charts should be on the wall, not on somebody's computer screen where they can hide it. It should be up on the wall in great big pieces of paper, and it should be modified every week. And what is that chart? What are these two charts going to tell you? They are going to tell you in no uncertain terms just how screwed you are. Because the news on those charts is seldom good news. It's real, but it's not good news. And we want the bad news out as early as possible. We want the managers to know just how much trouble we're all in, right? Because the promises have been made to the customer. Are we going to meet those promises? And the charts say no. But the charts say no pretty early on. So maybe we can do some work with the customer to help, right? That's the whole point. Agile is not about going fast. Agile is about knowing how fast you are going. Or more importantly, Agile is about knowing just how bad things are. We want the bad news out as early as possible. Every week, those charts get updated, and it's another big dose of cold water on top of all the managers wondering what the hell they're going to do to manage this project. That's why we do Agile. We do Agile to destroy hope. Hope is the project killer. Hope is the thing that makes people forge on ahead with a terrible plan when they could course correct if they only knew. And that leads us to the management paradox. What's the first thing you know about a project? Before you've got any requirements, before there's even a name for the project, there's one piece of data that you have that precedes every other piece of data. And of course, that piece of data is the date, for very good business reasons. I mean, there's a bunch of guys that sit in a room, management types, they're all in a room and they're saying, oh my God, we got to have something by November. It's got to be by November because there's a shareholders meeting in November, or there's a trade show in November that we've really got to be at, or we run out of money in November. That's a really good reason to be done by November. So for good business reasons, the date is chosen. Once the date is chosen, the date is frozen. There's no point in arguing about the date. The date was chosen for good business reasons. It doesn't have anything to do with technical reasons. The date is a business objective. Meanwhile, the requirements are never frozen because, we don't know what the heck we're building in most cases. Customers don't know what they want, really. Once they see it, they'll know they don't want it, but they don't know what they actually want until they see it. So we're going to be having to deal with frozen dates and volatile requirements, and that is the world that software developers live in. Software developers live in a world with frozen dates and volatile requirements, and somehow that has to be driven to a good outcome. Winston Royce wrote his waterfall paper so long ago in an effort to describe how to make that happen. How can we get this done? And boy, I remember when this came out. I was a young programmer when this came out, and the idea was, if we could divide the project up into phases and put dates on those phases, then we would know how far we were. We would know how done we were. If we finished analysis on July 1st, we knew that we were on schedule. If we finished design on September 1st, we knew we were on schedule. But it never really worked out that way. Winston Royce wrote his paper a long time ago. It was 1970. And this was the first diagram that showed up in his paper. And he said, this looks like the typical way that software should be done. Now, it's ironic. And I told you I'd get to this irony here pretty soon. This is ironic because on the second page of his paper, he said, yeah, that doesn't actually work. Because once you've gotten to the point where you're actually executing the code, you realize the design's all screwed up. And as you're working through the design, you realize that the requirements are all screwed up. And so there's this back channel, and you've got to kind of go around and around and around that loop. And in fact, what you've really got to do is just do everything in parallel. You got to do all these things in parallel. You can't do them in series. They just constantly all have to be done. That was the way he framed the issue. But apparently, nobody read that paper. All they saw was the diagram on the first page and thought, well, that looks like a pretty good diagram. And that diagram, this one right here, got photocopied into document after document after document and book after book, completely ignoring the final result of the paper that the document appeared in. That is the irony of Winston Royce's paper. Winston Royce is called the father of the waterfall because he wrote a paper that said, please don't do this. But everybody did it anyway because they really liked this picture. And so everybody started doing this. From the 1970s on, people started doing this, and the result was a significant amount of failure. Now, I can show you some results of the significant amount of failure. So here is one. This is a chart from a study that was done in the 80s by a guy whose name was Jarzembek. And he was studying $37 billion worth of Department of Defense projects that used 2167A, which is the waterfall process. Okay. And the legend has fallen off this chart, but I can tell you what those numbers mean. 46% of the projects were used. 20% could be rescued after significant rework, and the remaining N%, looks like 44%, were just simply thrown away. That's a lot of money thrown down the tubes, right? And all of that came out of the waterfall mentality. But the problem was actually worse than that, because of the delivered projects, 45% of the features were never used. 19% were rarely used. Only about 20% were used often enough to actually justify the project. So this is an immense amount of waste. And the United States Department of Defense recognized this waste. And so they commissioned a task force led by Fred Brooks. Now, I don't know if you know who Fred Brooks is. Fred Brooks is the guy who wrote The Mythical Man Month and a bunch of other very good books. But his real claim to fame is that Fred Brooks was the project manager of the IBM 360 operating system in the 1960s. Big, big deal. Virtual memory operating system, big piece of software for the time. And he led an army of developers to write the assembly language to make that operating system work. And so when the Department of Defense chose him for this task, they had a reason to choose him. So they said, hey, Fred, go out there and tell us why we're wasting so much money. And Fred Brooks came back with a task force report. And the essence of that report was this. It is the document-driven, specify then build approach that lies at the heart of so many of your software problems. In other words, the waterfall model is the problem that you're having. Now, why? Why was it a problem? Well, it's a problem because of this. Let's you and I go to a meeting. We're going to go to a meeting, and this meeting has occurred thousands of times in thousands of places over the last 50 years. And it goes like this. Big boss calls us into the conference room, says, got a new meeting, got a new project. Don't have a name yet, no requirements. It's got to be done by November. Now, how long will it take you to do the analysis? Well, we don't have any requirements yet. We don't. No, don't give me any of that nonsense. You guys are professionals. You've been through this before. Keep in mind that if we can't get it done by July 1st, we might as well not do this project. July 1st, I hear you say, excellent. Now, how long will it take you to do the design? We haven't analyzed anything yet. We don't know what this project is. No, you guys are professionals. Keep in mind, If it takes any longer than September 1st, we might as well not do this project. I hear you say September 1st. Excellent. That leaves us 2 months for implementation. Now get the hell out of here and start working. Now, maybe you have not been to that meeting. Although it looks to me from the emoticons coming up that some of you have been to that meeting. I've been to that meeting a few times. So now, here's the question. We've just left that meeting. What the hell are we doing? Well, we're at the beginning of the analysis phase. So apparently what we're doing is analysis. Well, what the hell's analysis? I don't know. I don't know what analysis is. Tell you what, you go out and you get a few books on analysis. There's a bunch of books written about analysis. And see if you can come to a conclusion about the common things that everybody says about analysis. And I guarantee you that when you're done with that, you will realize that there is no common definition of this word. Nobody knows what analysis is. The best definition of analysis is that it's what analysts do. So yeah, that's what we're going to be doing for the next 2 months, analyzing, but we don't know what that is. So some of us will be drawing data models, and some of us will be drawing behavior models, and some of us will be coming up with a functional specification, and we'll talk to the customer, and we'll write down a bunch of interesting things, and we'll do some day trading. This is the honeymoon part of the project. The deadlines don't really mean anything. They're so far away, and it's easy to do analysis because who knows what the hell it is. And so for 2 months, we do all of this busy work. And then on July 1st, a miracle happens. What happens? We're done with analysis. Why are we done with analysis? Because it's July 1st. There's no closure criteria. There's nothing to test to see if you're done with analysis. There's no way to know that you are done with analysis. The only piece of data you have that tells you that you are done with analysis is that you are supposed to be done with analysis on July 1st. And so, I mean, who wants to be late? We have a little party, balloons and speeches as we go through the phase gate into the design phase. Now what are we doing? Well, we're designing. Well, what's that? Well, now we definitely have some resolution on what design is, right? When we're designing things, we are breaking things up into modules. We're also breaking things up into teams, and we're doing feasibility, and we're trying to figure out, well, we need 5 people for that team and 3 people for that team and 6 people for that. We're trying to work all that stuff out, and we're working all the interfaces out. You know, we're drawing diagrams, all this stuff, and we got to do this for 2 months. Okay, well, we'll just do that for 2 months. Meanwhile, the customer's calling up and saying, you know, those features we told you really needed. Well, we don't really need them anymore because the customer that was going to use them is left us. But there's another guy that we think we could get to buy it if we had these features. So can you please put these features in it? And we're like, well, wait a minute. We haven't analyzed any of those features, but we can hack them into the design if you want. So we hack them into the design somehow or another. And then it's September 1st. And what happens on September 1st? Well, we're done with design. Why are we done with design? Because it's September 1st. Once again, there's no closure criteria. There's no way to know that you are done with design. You can do design work until the date. And so we do. We do it until the date. It's September 1st. Nobody wants to be late. So we might as well be done on time, and we'll have another little party, balloons and speeches, as we go through the phase gate into the implementation phase. Now what are we doing? Well, it's completely obvious what we're doing now. We're coding. And we'd better be coding like mad banshees because we've blown 4 months of this project. So now we're writing code. And boy, oh boy, are we writing code. Code, pouring out of every orifice of our body. And as we look back at the design documents, we think, well, we don't know what we were smoking when we did those design documents, but this code is not coming out anything like that. Meanwhile, the customer's calling and saying, yeah, we got another feature for you. Can you throw that in there too? Don't have time to design it or analyze it. We're just going to hack it in, and we'll hack sometime around October 15th. One of the developers sticks their head up above a cubicle and says, hey, it's October 15th. There's only 2 weeks left. There's no way we're going to be done with this project. And this is the first time that any of the stakeholders hear that maybe there's a problem with this project. And the stakeholders are, shall we say, not pleased. The stakeholders are going, what? What? 2 weeks before the deadline, you're telling us you're not going to get done? I mean, couldn't you have told us this back in May? Weren't you doing feasibility? Weren't you sizing the project? Weren't you figuring out that it was possible to get it done by November? What about during July? You were doing the module breakups. You were sizing the teams. Couldn't you have told us this during July? Why did you have to tell us 2 weeks before the deadline? And they've got a point. So now the project enters the death march phase, and we work and work and work for months, and morale goes into the toilet, and people are quitting, and life is hell. And sometime in March, we deliver some limping thing that sort of half does what the customer wants. And we come out the back end of that process, literally the back end of that process, and we say to ourselves, by God, we're never going to go through that again. Next time we'll do it right. Next time we'll do more analysis and more design. You see, I call that process inflation. We take the thing that didn't work and we do a lot more of it. That's what happened to waterfall. It got worse and worse with time. These kinds of episodes started to occur more and more as the cost of change went down. The cost of waterfall went up. So now, what does it look like if we switch this to an agile process? So here is a picture of an agile process. We're going to do this the easy way. Now, once again, first thing you know is the date. We've got to be done by November 1st. So the lower right-hand corner down there is November 1st. We've got to be done by then. Okay, fine. You see that big white block at the top called exploration? Well, that's all the analysis and design stuff. You know, whatever that analysis and design stuff is, that's where that happens. We're doing that. We're exploring requirements. We're feasibility studying. We're doing team analysis. All that stuff is happening up in that exploration part, which you will notice never ends, or at least it ends on November 1st. It goes along in parallel with the rest of the project. Then if you notice below that, there are these vertical bars. The vertical bars we call sprints if you're doing Scrum, iterations if you're doing some other process, doesn't matter. And they're all of fixed size. Now, I like 1 week. I think 1 week is the best size. Some people like 2 weeks. 2 weeks is acceptable, but a lot can go wrong in 2 weeks, so I prefer 1 week. Some people do 1 month iterations. That's too long. That's just too long. It's way too much can go wrong. So I'd like to keep these nice and short. You and I, for the purpose of this exercise, will assume that they are 1 week long. The very first iteration is actually mostly exploration. So that white exploration thing on the top really leaks down into that first iteration. And we're not really thinking we're going to get any working code out of the first iteration. Some people call this sprint 0 or iteration 0. That's fine. Most of what's going on there is requirement stuff and setting up the source code control system and making sure that everybody's got a workstation and all that nonsense that has to be done at the very beginning of the project. The second iteration, that's where we really start working. Now, what are we doing here? During that first iteration, we are coming up with that, iteration 0. During iteration 0, we're coming up with a list of, and we'll call them stories. In Scrum, they're called backlog items. Too many syllables. Stories is a good word. Or if you wish, you could call them use cases. Same idea. It's just, little bits of features. They're not full features. They're not really big features, right? They're bits of features. We come up with a big list of them. And then we schedule them out. This is all part of iteration 0, right? We schedule them out across the other iterations, the other sprints. So we say, okay, in sprint 1, we're going to do these 2. And in sprint 2, we'll do those 3. And in sprint 4, we'll do these. And in sprint 5, we'll do those. And we kind of lay them all out. And of course, they've got to all be done by November 1st. So we lay them all out and we think, okay, well, that's a plan. Then we start to actually do iteration 1. Now, iteration 1, we've got 3 stories that we're supposed to get done in iteration 1. So we begin to work. Now, we don't have any design and we don't have any analysis. All we've got are these stories. And maybe we've done a little bit of scribbling on whiteboards to do some analysis and design, but not a lot because we've only got the 3 stories. By the way, it's a good idea. Go to the whiteboard, scribble out a few UML diagrams if you want to. It's not a bad thought. But don't believe them because they're probably wrong. In any case, we start to work. And do we get all 3 stories done in that first iteration? Come on now, don't BS me. We're not going to get all 3 of them done, are we? No, because we're lousy at estimating. Everybody's lousy at estimating. All programmers are lousy at estimating. There's no good way to estimate stuff because we've never done it before. So we kind of, go, oh, well, I think we can get all 3 of those done in a week. Well, we didn't. So the first iteration ends, and we only got 1 of those stories done, and the other 2 we did not get done. That's the bad news. And we capture that bad news that way. If that's how fast we're actually going, well, we're not going to be done until March. Now, I drew that out there at the end there, and you notice those red brackets? Well, those are the error bars because we've only got 1 data point right now. So the error bars are huge. Although you'll also notice that the error bars do not include November 1st. So the news is not particularly good. On the other hand, only 1 week has gone by, maybe 2 if you count iteration 0, right? So only 2 weeks have gone by. Maybe things will get better. Hope, right? There's always hope. Maybe things will get better. So let's do the next iteration. And as we do the next iteration, things do get better. Now, why do they get better? Well, because we've got a little bit of an architecture and design going. Not much, but a little bit. And that helps. And we all our problems with the source code control system have gone away now. And we kind of got a flow going. And by the time we get the next one done, we got most of the stories done. Didn't get them all done. We got most of them done. Let's do another one. Let's do another week. So we'll do another week. And things are getting a little bit better. Okay. And the customer calls and adds a new feature. Well, and by the end of that, it looks like this. Okay, we've gotten 3 of them done, and it looks like it's still out there in March. But the error bars have really tightened around March. Looks like it's going to be March, doesn't it? We are 3 weeks in, maybe 4 if you count iteration 0. And we already know that we are not going to make November 1st. And there is very little hope that we're going to make November 1st. Hope has been destroyed here, and it looks like it's going to be March. Well, what do we do about that? We now have very reliable data that we are not going to be done by November 1st. It's going to be March. What are we going to do? The date is not going to be met. Well, maybe there's a way that we can meet the date well, let's wait. Let's wait. Because the managers are still stuck in dictate and motivate mode. They're still saying, it's got to be done, it's got to be done. And you're the only guys who can do it. But we've got this data. And the data is telling us, no, we're not going to get it done on time. So what do we do? Now I want you to put yourself in the role of the project manager. You're the project manager. You've got to drive this project to some kind of a good outcome. And it does not look like the outcome is going to be the one that was planned. Here are the knobs. Remember those knobs back from the Iron Cross of project management, right? Good, fast, cheap, done. Here they are again, although I've renamed them. Schedule, staff, quality, and scope. And the very first knob that maybe we can turn is the schedule. Let's go to the stakeholders and ask them if it's okay if we deliver in March instead. And the stakeholders hear that and they go, no, we need this in November. I mean, we're going to be out of money if you don't deliver this in November. We got to have something by November, damn it. Now, by the way, sometimes when you go to the stakeholders and say, yeah, it looks like March, guys, the stakeholders will go, oh, well, okay. I mean, we were planning to go to that trade show in December. But yeah, there's another trade show in April. We'll go to the one in April. It's a good thing you told us this now because we were about to buy booth space at that December trade show. And, those are contracts. You can't end those contracts. You can't cancel them. We would have spent tens of thousands of dollars on that trade show booth. It's a good thing you told us this now. So sometimes when you present the bad news to the stakeholders, it's actually not that bad. Now, that's not the usual case. In the usual case, it's pretty bad, and the stakeholders say, no, it's got to be November 1st. But there are times when you can turn the schedule knob, and everybody kind of goes, okay, we'll just turn the schedule knob. Thanks for letting us know. Let's assume, however, that we cannot turn the schedule knob. Okay, let's try the staff knob, right? This is the cheap one. Now it's not going to be quite so cheap. We're going to spend more money on this, right? Let's add more people to the project. Now, everybody knows that if you double the staff, you go twice as fast, right? Isn't that what happens when you double the staff? You go twice as fast, right? So no, that's not what happens. What happens when you double the staff or add any staff is this. You started out at some kind of starting productivity. The moment you add new people, productivity goes down. And it goes down because the new people suck the life out of the old people. They've got a million questions. They do everything wrong. The old people are trying to fix all the messes that the new people are making for, a month or 2 or 3. So you're going to lose productivity for a period of time. But then the new people get smart, you hope, and the goal is that your productivity will rise. Now, the question here is do you have enough time to make up for the loss? If you do this early, you may have enough time to make up for the loss. I've actually done this. I had a project that was way behind, and we found out within the first 10% of the project and decided we had to add a bunch of people to the staff, and we did, and we brought the time in, and we managed to deliver on time by adding staff. You can do it if you do it early enough. If you do it late, well, then Brooks' Law comes into effect. Brooks' Law, same guy, Fred Brooks. Adding manpower to a late project makes it later. So that's one reason you don't want to turn the schedule knob. The staff knob. If it's early enough, maybe you can. But there's another reason why you don't want to turn the staff knob, and that is that you're going to spend more money per month because you got to pay these people. So maybe we don't have the budget. So, okay, all right, let's say we cannot turn the staff knob. We can't turn the schedule knob. We can't turn the staff knob. There's this knob down at the bottom called quality. Let's see if we can turn that one down. Yeah, because everybody knows you can go a lot faster by producing a big pile of crap. So let's do that, right? So the managers say, okay, guys, we want everybody working 50, 60 hours a week. We want you in here on weekends. And I don't want any unit testing. I don't want any code reviews. I just want you writing code. Now, this can have the unfortunate appearance of working because all the developers are now working very hard. And you can see that they're all working very hard as the sweat pours off their body, right? Every ounce of energy they try to give away, the old Rob Seeger song, right? So okay, they're all, working really hard, but what you don't know is what they are doing. They are no longer writing the code for the project. Most of their time now is in moving around the mess so they can make the next little bit of a mess for somebody else to move around. And the entire effort has turned into moving mess around instead of adding new productive code. As a rule in software, you want to go fast? Do a good job. The only way to go fast is to go well. what we're going to have to do with the quality knob is take it and turn it up to 10 and leave it there. Can't turn it down. If you turn down the quality knob, you're going to slow down. So you just have to keep that knob high. And that only leaves one knob left, the scope knob. Maybe, just maybe, some of those features don't have to be done by November. Let's go back and ask the stakeholders. Hey, stakeholders. We got all these features we haven't done yet, and if you can take some of them out, we can get done by November. You just have to take, I'd say about half of them out of there. Take half of them out, we can be done by November. And the stakeholders say, no, we need it all. And we need it all by November. And we say, well, stakeholders, I mean, look at the data. The data tells us we're not going to be done by November. I mean, if you need it all, it's going to be March. But we can get done by November if you take some of those features out. And the stakeholders go, no, we need them all. And this little argument will go on for some period of time. And whereas the stakeholders have the moral right to insist upon all the features being delivered on November 1st, the developers have the data. And the data is incontrovertible. And in any kind of rational organization, the data will win. By the way, the data will win even in irrational organizations. It's just when the data wins. And we'd like the data to win early enough to have a good effect. So let us assume that our organization is one of those in which the data wins early and the stakeholders say, oh, damn it, all right. We hired the wrong programmers for this. All right, we don't need that. We don't need some of these over here to the right. We don't need those. You can get rid of those. And say some of these here in the middle. Yeah, we can probably do without those. And then the stakeholder says, you know, those ones over there to the left that you've already finished, it's a real shame you finished those because we don't need them at all. Now, that's not a good outcome. We don't like that outcome. So from now on, before we start any features, we're going to ask the stakeholders if they want them. Every Monday morning, we're going to go to the stakeholders and say, hey guys, this is our plan. Do you want us to work on these today? Because if you don't think we need these, we'll put something else in there, because we never want to work on a feature that is not absolutely necessary for the outcome. What you've just heard is the Agile overview. This is Agile at the 30,000 foot level. Agile is pretty simple, right? We take the project, we break it up into a bunch of fixed size increments. We load those fixed size increments up with what we think are fixed size units of work, right? We execute them one at a time, and we measure how much we actually got done. And we use that measurement to plot out when we are really going to be done. And we execute these stories in order of business value so that we get the most important ones done first. That's Agile. That's it in a nutshell. We're going to, in the next hour, we're going to dive into some detail. But that is Agile. That's what Agile is all about. And with that, it is time to turn to the Q&A widget. If you have burning questions, type them into the Q&A widget. And there's one there. Ian says, Uncle Bob, can you please let us know how new staff should be added to a project without sucking life from the other people in this project? No, there is no way to do that. If you add new people to the project, those new people will reduce productivity for a period of several weeks, because there's no way that they can interact in the project without talking to the old people and learning from the old people. That's just the way it is. So no, if you're adding new people, you must expect a period of several weeks where productivity will go down. Then after that, you kind of hope that productivity goes up. There are reasons, by the way, that productivity will not go up. It will not exceed the previous value. And those reasons are beyond the scope of this particular class, although I will say that it has to do with the quality of the code. If the quality of the code is low and the new people are taught to perpetuate that low quality, then the productivity of the team will go down no matter what you do, unless you finally decide to clean up that mess. And with that, there are no other questions in the Q&A widget, so I'm going to turn on the 10-minute break. We will break for 10 minutes, and when we return, I will go into some detail on what all that agile stuff is. Okay. Well, must be close to 10 minutes. I don't know if the timer expired or something like
Yeah,
that.
the timer did stop, Bob, so it is all back to you.
Very good. Thank you. Ready. Okay. Welcome back from break. Okay. Back. Here we come. So, there we are. So now we're going to get into a little bit of detail. The detail we're going to go into is going to be in one particular area. So let me show you what the whole landscape looks like. This is called the circle of life. So named by Ron Jeffries 20 years ago. Ron Jeffries drew this particular diagram, and it has been copied many, many times since then. I think this version of it is a version that I copied from his. These are the practices of extreme programming. Now, why am I using the practices of extreme programming? Because extreme programming is the best defined of all the agile processes. All the agile processes are still agile processes. So there's Scrum, which is probably the most popular, and there's FTD and DSDM and a bunch of others. Of them all, though, the process that has the most definition in terms of both depth and breadth is extreme programming. So I have chosen it here as the basis. Now, these practices are divided into three areas. The green outer ring, those are the practices that face outward from the development team towards the business. And we are going to be focusing on just one of those practices, the one at the far right, called the planning game. The others, I'm not going to say too much about in this session, although if there's time, I might talk about the one at the far left, which is acceptance tests. The circle in the middle, the blue circle, these are the team-facing practices. These are the practices that the team of developers use between themselves. And I'm not going to go into great detail on these. Some of them require an awful lot of discussion, like metaphor down there. That one requires a lot of discussion. And if you want to learn more about that, go get Eric Evans' wonderful book, Domain-Driven Design. That's all about the metaphor problem. The rest of those, I'm not going to spend a lot of time on here. The inner circle. These are the individual engineering practices. Individual programmers practice these for their own benefit: refactoring, simple design, pairing, and test-driven development. These are the engineering programming practices used by individuals. So that is the way these three circles lay out, and the practices of extreme programming are organized. Our goal for the next hour is to focus on the planning game. The planning game is the story I just told you in the last hour. I told you about that project that had to be done November 1st and how we did it in an agile way. Now I'm going to give you some of the details about how we would do that in an agile way. And we begin with this whole business of stories. What the devil is a story? Now, I don't want this to get too carried away. There's been probably way too much written about this. A story is a use case. That's all. It's just a use case. Sorry. What's a use case? A use case is a description of how the system behaves given a particular input from the user. So the user does X and the system does Y. That is a story. That's what a story is. That's what a use case is. That's what all these things are. And we try to divide them up into fairly small use cases, fairly small stories. Now, the best way to give you an idea of that is to actually go through an exercise. So you and I, for the next 10 minutes or so, are going to choose the stories for a system that we all know very well, an automated teller machine. Let us assume that the concept of an automated teller machine is brand new, and we are the developers sitting around a table with the stakeholders telling us about this grand new idea and how we have to implement the software for it. So we have a meeting. And this would usually be on the first day of Sprint Zero. So, okay, Sprint Zero's begun. We're all having a meeting. The stakeholders are there. QA is there, the developers are there. It's a fairly large meeting. Maybe there's a dozen people. And the stakeholders begin and they say, man, we got this great idea. We were going to build this machine. The hardware is actually already done, and we just need the software for it. It's an automated teller machine. Please, guys, give us an automated teller machine. And one of the programmers says, well, can you tell us what it does? And the stakeholders say, well, it delivers cash to the users. I mean, you go up to this thing and you say, give me $500, and it'll give you $500. And the QA person stands up and says, wait a minute. Anybody can walk up to this thing and get $500? And the stakeholders say, well, no, you have to have an account at the bank. And one of the programmers says, well, how do you know? How does the machine know that you got an account at the bank? And the stakeholder says, well, what we've done is we've mailed cards with a magnetic stripe out to every account holder. And if you put that card into a slot, then the machine knows that you're an account holder. It even knows your account number. And one of the developers says, well, wait a minute. If that card gets stolen, that means all my money it can be stolen. And the stakeholder says, no. There's a password, a PIN number, a personal identification number that you have to enter. So you put your card in the slot and you punch in your PIN number on the tablet there, on the keyboard there, and that's when it lets you in. That's when it knows that you are real. Programmer goes, okay, wait a minute. That sounds like a story. And we're going to call that story login. And it goes like this. Let me see if I've got this right. You walk up to the machine, you enter your card in the slot. There must be a prompt on the screen that says, please enter your card. So you put your card in the slot, and the machine reads the card, and then it asks for your PIN number, and you enter your PIN number on the keyboard, and then it welcomes you into the machine. So now you are logged in. And the stakeholder goes, yeah, that's right. Although we don't know what the word log in means, but okay, yeah, that's how you gain access to the machine. And the programmer picks up a white index card and writes the word login on it. That's all he writes. Login. He doesn't write any paragraphs of all that stuff. He doesn't write down the steps. He's not doing any of that. He writes the word login on the card, and he puts that down on the table. That's the first story. Now, why isn't he writing any more down? The word on the card is a memory device. These are like memory cards, flash cards. The purpose of the card is to remind you of the conversation you just had. And there's a lot of people in the room, and if we get all those people back in the room and we hold up that card, they will be able to reproduce that conversation. So we don't need to write anything down yet. We will later, not yet. There's a reason why we don't want to write things down. All the details are going to change long before we ever have to implement anything. So we don't want to write down a bunch of detail yet, because all that detail is kind of ephemeris. It's going to change. We want to record the essence of what happened, but we don't want the details nailed down yet. There will be a time to nail down the details. It's just not yet. So the conversation continues. And the programmer says, okay, well, so what can the guy do? And the stakeholders say, well, you can withdraw money from your account. And the QA person says, what if you've got two accounts, like a savings account and a checking account? And the stakeholder says, well, yeah, there'll be a menu selection for that. So it'll ask you the question, which account do you want to withdraw from, savings or checking? And then you'll have to push the right button. And programmers go, there's buttons? And oh yeah, there's buttons on the side of the screen. That's right. And we can point at the buttons. So the screen can have little arrows that point at the buttons that you're supposed to push. And the programmers go, okay, all right, I think I get that idea. All right, so you can withdraw money. So you select the account. This is the programmer talking. You select the account, and then I presume it's going to ask me for how much money I want to withdraw, and I can enter that. And then if I say yes, what'll happen? And the stakeholder says, well, money will appear in a drawer, and you'll be able to take that money out. And the QA person says, wait a minute, what kind of money is going to come out? You mean in coins? And the stakeholder says, no, bills. And the programmer goes, wait. Like ones and fives and 10, and the stakeholder says, no, just 20s. Just that's all we do is 20s. And the programmer goes, oh, so the amount you ask for has to be an amount divisible by 20. And then the stakeholder, yeah. You do it in 20s. Okay, fine. Oh, QA guy says, wait. What if the machine doesn't have that money? And the stakeholder's getting frustrated at this point. He says, well, we'll put up a message saying we don't have enough money. And this QA guy says, what if the money gets jammed? Can it get jammed? And the stakeholders are like, shut up. Don't you understand how cool this is? And they're saying, okay, all right, yeah, it can jam. You'll have to put up a message, and we'll have to send an email to the maintenance guy so that an email? Does this thing have an internet connection? Yes, it's got an internet. So you see how this goes, right? This is how this is going. This discussion back and forth. We're discovering what's going on. And during that time, we start writing down these cards. And the cards come out. There's the login card. There's the withdraw card. There's the deposit card. There's the transfer card. There's probably a bunch of other cards, too. And by the time an hour has gone by, we've got 20 or 30 cards. Okay, well, that's good enough. Now the meeting is over. The stakeholders are tired of these whiny programmers who are so detail-focused all the time. Can't they just enjoy the abstract glory of our creation? But no, they can't. And programmers and QA people are very detail-oriented. So now the stakeholders go away, and the programmers are all sitting around going, well, we should estimate these. And somebody picks up the login card and says, okay, guys, gather around. Login is a 3. And the rest of them say, 3 what? And he says, I don't know, 3. But if login is a 3, what's log out? And he picks up the logout card. And everybody looks at it and they say, well, it's a 1. I mean, it's hardly anything. Logout's simple. And okay, they put a 1 on it. So now there's a 3 on the login card. There's a 1 on the logout card. Then he holds up the withdraw card. How much is this? Well, if login is a 3, withdrawal's a lot more complicated than that. I mean, probably a 6. And they put a 6 down on that card, on the withdrawal card. And then the next one comes up, deposit. That's not as hard as the withdrawal, because we're not spitting any money out of the slot, but we do have to suck an envelope in, and that's kind of hard. 5. It's a 5. And it goes like this. It's all very gut level, right? The estimates are just kind of about a 5, just like that. And we put all those numbers on the cards. So then begins the sprint planning meeting, or the iteration planning meeting. This usually occurs on a Monday. Usually it's Monday morning. It would occur on the very first time it occurs would be at sprint 1, after sprint 0 is over, after iteration 0 is over. All right, Monday morning, we all get together, stakeholders, QA, developers, all in the room. And we're going to plan out the first sprint. And the developers say, okay, which stories do you want us to do first? And the stakeholders say, well, how many can you do? And the programmers say, well, you see those numbers on the cards? We don't know how much of that we're going to get done, but let's just say that we can do cards that add up to 10. And the stakeholders say, just 10? I mean, one of these cards is a 6. It's like that's like almost the whole iteration. Yeah, just 10. It's going to be 10. So pick cards that add up to 10. Where'd you get this 10 from? There's no science behind it. We just picked 10. Don't worry. If we go faster, you'll be able to add more cards. Just don't worry about it. Just give us cards that add up to 10. So now starts a fascinating process. Let me show you what that process looks like. It's a really interesting process. The stakeholders are now faced with this quadrature. They're going to pull out cards, and they will see the cost on the cards. That's that number that we stuck on the card. And they know the business value of the card. And they've got to play those two things against one another. So there are going to be important and expensive cards up at the upper left there. There's going to be important but cheap cards at the upper right. There's going to be unimportant and cheap cards at the lower right. And there's going to be unimportant, expensive cards at the lower left. And the stakeholders are going to want to pull from the upper left as much as possible. Why? Well, actually, they're gonna want to pull from the upper right even more. But they also want to pull from the upper left because they're all important. But the upper right? Oh my God, look at the upper right. Those are important cards, but they're cheap. That means the return on investment is really high. We get a lot of business value for a really low cost. So they're really interested in that upper right corner, the important and cheap corner, but they can't ignore the upper left corner. So let's go through the logic here. Stakeholders are sitting there going, okay, log in. It's a 3. That's like a third of the whole thing. Okay, it's really important, but it's expensive. We're going to wait. We're not going to do that yet. Log out. That's important, but it's cheap. Yeah, go ahead and do it. Log out. So could you do log out before you did log in? Of course you could. I mean, you're programmers. You fake them logged in the database, and then you log them out. You demonstrate the log out process. You don't have to implement login. Right? There are no orders to these cards. Well, let me say that differently. There generally are no orderings to the cards. Usually, because we are programmers, we can circumvent any surface ordering that people might infer to the cards. Like login's got to come before log out. Well, no, it actually doesn't. Are there sometimes orderings? Yeah, sometimes there are orderings because sometimes one card is a superset of another, but we're not going to talk about that just yet. Okay. So now the stakeholders pick up the withdraw card and they look at it really seriously. Oh my God, it's a 6. It's 2/3 of the whole iteration. But I want to see money coming out of the slot. We're doing that one. This is the way it goes, right? This is a return on investment priority kind of sorting. The stakeholders go through the deck and they pull out the highest return on investment they can get from that deck, which leaves the deck reduced in return on investment. The value of the deck has now gone down, not just because we pulled some features out, but because we pulled the highest return on investment out of it that we could get. Don't worry, there's a solution to that as well. But now the stakeholders are pulling out these high value cards. And in the end, they pull out cards that add up to 10. Okay, we're off to the races. Now we do the iteration. For 1 week, we are going to be working on those cards. Now, I don't want to describe the mechanism here. There's a lot of detail that goes into the middle of an iteration. I'm just going to tell you this. There is a process by which cards move from the undone pile to the done pile. A lot of people like to have these sticky walls, and they will put the literally cards, right? They will put the cards on the sticky wall, and then as the cards change state, they will move the cards around. So, during the middle of the iteration, it might look something like this. By the way, cards. I know, it's 2024. Everybody's got to use some kind of automated tool for everything. Okay, fine. Here's my advice. If you have never done Agile before, don't use a tool. get index cards, use index cards for a month. That'll get you used to the process very well. And then once you're used to the process and you know how to do it, then you can go look for a tool if you absolutely have to have a tool. You can go get a tool, and the tool, can be this gigantic pool table, right? Big touchscreen pool table with cards on it, and you can move the cards around on the table. Wouldn't that be cool? And you'll pay $250,000 for it, and it'll be really cool. Or you can use index cards. World War II was managed on index cards. I think the process scales just fine. Anyway, now we're working. And we're moving cards from the undone pile to the done pile. This is a 1-week iteration. On Wednesday at noon, halfway through the iteration, what should be the total of points in the done pile? To do this process, you must be able to divide by 2. There should be 5 points in the done pile on Wednesday at noon. But there's not. There's only 3. We are not going to get all 10 points done, are we? There's only 3 done points in the done pile at the midpoint. And oh, by the way, I forgot to tell you, there's a meeting at the midpoint. All the stakeholders, QA people come into the room and they look on the wall and they see, oh, you only got 3 points over there in the done pile. And the stakeholders are like, you guys aren't going to get done on Friday, are you? And developers are like, no. What you're going to have to do is take some of those cards out of that selected pile because we're not going to get them all done. The stakeholders are like, come on, you guys. We got to get this thing done. You got to get 10, 12, 15 points a week done. And then the developers are like, look at the board. That's what we got. Take some of those points out. Otherwise, we're just going to have a mess of an iteration. And the stakeholders take, they got to take 4 points off. Because there's only 3 points over there. They're only going to get 6 points done at most. So they have to take 4 points off the board. And they're disgusted. The stakeholders walk out of the room disgusted. They put things back in okay, make a long story short, Friday comes along, and by some miracle, we actually did get 6 points done. And we go back to our charts. Remember the charts on the wall? Here they are, the charts on the wall. And we say, okay, we draw our first chart on the wall. Yeah, okay, we got 6 done. Put that on there, mark down the burn down chart. If you got one, you might not have a burn down chart yet. That burn down chart might come later. But the velocity chart you've got, you can put that on the velocity chart and off you go to the races. And now we start again. It's Monday. Oh, by the way, I should say, Friday evening, Friday afternoon, an hour before everybody goes home, there's a little demo, right? And all the stakeholders come into the room and we show them what got done. And by the way, the best way to do this is to have the stakeholders operate the machine. Stakeholders, look, we can log in. Yeah, okay. Or we can log out or something like that. And you let them operate it and they can see, oh, yeah, okay, well, you actually did get something done there, didn't you? It wasn't a lot that you got done. Guys are going to have to go faster than this, but okay, you got something done. By the way, what happens at that last meeting, that last 1 hour meeting where you get everybody in the room and you demo, is that the stakeholders will often go, wow, that's the way that works, is it? I remember telling you that it should work that way, but now that I see it, I don't want it to work that way. At which point they have to write a new card and put that in the pile, and we'll estimate it later, and that'll show up at another iteration. Okay, we go home. Life is good. We come back on Monday. And we start that process all over again. Iteration planning meeting. Okay. And stakeholders say, okay, 10 cards, right? You need 10 cards, right? And we say, no, we only got 6 done. So you got to give us 6. You said you could do 10. No, we only got 6 done. Give us 6. The stakeholders are like, we're never going to get this project done. But they give you 6. And now you work. And Wednesday at noon, you go back. Wednesday at noon, we have a little meeting. And there's 4 points in the done pile. you guys are going to get 8 done. And the stakeholders slam 2 more points on the board. And, Friday comes along and we didn't get all 8 of them done. We only got 7 of them done, but that's pretty good. And we go back and we draw our bar charts on the bar wall. Okay, now we've got more velocity up there. And we come around and it's Monday. Oh, we do the demo, the demo's fun. Everybody's happy with the demo. We go home and now it's Monday. And stakeholders are there and say, well, okay, I suppose you're going to tell us you want 7 because you got 7 done last week. And we say, yeah, that's right. Just give us 7. This is called yesterday's weather, by the way. The best predictor of today's weather is yesterday's weather. It might not always be right, but the best way to guess it is to just look at yesterday. And so, okay, we always ask for whatever we got done the last time. Always? Well, no. I mean, if somebody's sick, you can reduce it. If you got a new guy, you can reduce it. But okay, fine. This continues in this way. Stories moving, going from the undone pile to the done pile. The charts continue to build more and more velocity bars. Eventually, we come up with a burn down chart because we finally got some kind of deliverable we need to do. So we estimate that out. And okay, fine. And life is good. You get into a rhythm. You develop a nice little velocity. Cooking along. The stakeholders get to see progress every week. They get to see how much gets done. They get to trust what's going on. Everybody gets happier and happier. The deck of cards continues to grow because every week at least, the stakeholders come in and say, we got some new ideas for features, and you write them down, have a little meeting just like that first one, and then you estimate them just like that first one. And okay, so the deck is continuously growing, but it's also continuously shrinking because every iteration we take some more cards out of the deck. The value of return on investment, the ROI value of the deck, remains relatively constant so long as the stakeholders keep on adding more stories into that deck. So this quadrature thing here, right? They keep on adding stories, and some of the stories they're adding are important and expensive, and some of the stories they're adding are important and cheap. And sometimes they add unimportant stories that are cheap or expensive too. So the quality of the deck remains relatively constant for a long time. But at some point, the rate of new stories going into the deck begins to slow. The stakeholders have no new ideas. The system has got just about everything they need. They don't need anything else. They stop adding cards to the deck slowly, bit by bit. They stop adding cards to the deck. And the iteration meetings get less and less interesting because the stakeholders are sorting through the deck going, I guess we could do that one. I guess we could do that. Yeah, okay, do these. That's fine. And they walk away. They're losing interest because the stuff in the deck is not very interesting. At some point, you're going to come to an iteration meeting, and the stakeholders are going to look at the deck, and there's nothing in there worth doing. Project's over at that point. The project is not over when all the cards are done. The project is over when the stakeholders realize that there is nothing in the deck worth doing. And it's amazing to look in the deck at that point and see what's remaining in there, because sometimes the stuff in that deck was really important early on, and it's not important now. I once worked on a project where the very first card written, the card that gave the project its name, never got played. And when the project was over, that card was still sitting at the bottom of the deck because everything had changed. By the time we got, there was always something more urgent to do. There was always something we had to get done before we did that one. And as the months went by, that one got less and less important and never got done. It's just the way that goes. And that's just a way of understanding that what gets done in an agile project is the most important stuff that can be done at that time. The stakeholders are constantly trying to figure out the highest return on investment they can get. Okay. Now that's kind of the highest level picture, or the mid-level picture of what's going on. There's a bunch of interesting little details that we should talk about. Number one, how do you do estimates? And the way I like to do estimates is as simple as possible. You know, I talked about these numbers, logins of 3, withdraws of 6, that kind of thing. Well, how do you do that? So you get all the developers in a room and you say, all right, we're going to estimate these stories, and the stories can have as many points as there are fingers on your hand. We're not going above 10. That's it. Not going above 10. No story card can have more than 10 points. Or if you'd like to limit it to 5, limit it to 5. You know, you can do it either way. In fact, 5's not a bad one. So let's say 5. Okay? You can have the number of points you can have on the card is 0 through 5. Okay. Now, pick a card. Everybody's sitting around the table, pick a card. Ooh, it's the login card. What do you think? And we talk about it for a minute. Well, what do you got to do for login? Well, you got to stick your card in the slot. You got to enter a PIN number. What if you enter it wrong? Well, you got to enter it again. How many times can you enter it wrong? 3 times. What happens after that? You eat the card. Okay, fine. After that discussion, somebody says, okay, let's estimate this. Put your hands behind your back. Everybody puts their hand behind their back. They stick up the number of fingers they think that card is. The guy says 1, 2, 3. Everybody brings their hand out, and everybody can see what the estimates are. And if they're all the same or very close to the same, then you just say, okay, 3. Right? If everybody's got a 3, or some people have a 2, and one guy's got a 4, you think, okay, fine, 3. If there's a major disagreement, like one guy's got a 1 up and the other guy's got a 5 up, you say, well, talk to those 2 guys. Why do you think it's so simple? Why do you think it's so hard? And let them talk. And then just repeat the process, right? Okay, hands behind your back, everybody. And eventually it will even out, and then you can put that number on the card. That is a process that I call flying fingers. It is a variation on a very formal process called wideband Delphi, but you don't want to know that. This is just the most informal version of wideband Delphi you can get. Hand behind your back, boom. Would you ever say 0? Yeah, there are some cards that, well, they could be done already, or they're just so trivial that there's no point in estimating it. Okay. Sometimes you got a feature, and everybody's estimating it and saying, it's more than 10. I can't do it. It's more than 10. So you've got to split the card, right? You got to subdivide the card up so that you can get all the numbers below 10 or below 5, whatever your maximum number is. Some people use 3, right? They say shirt sizes, small, medium, large. Okay, you can do anything you want. It's up to the team to pick the scale of the stories, but pick some relatively small range. Some people like to use the planning poker cards. You can get these from, Mountain Goat software, or a bunch of other people have made these planning poker cards. They're actually a deck of cards. They look like playing cards, but they've got numbers on them. And you divvy them out. Everybody's got the same numbers. And then instead of pulling your fingers out, you just put your cards down. And cards have, 1, 2, 4, 5, whatever. Some people have gotten clever and made a Fibonacci series. I'm not quite sure why they did that, but okay, never mind. Sometimes you will have a card that you cannot estimate because you just don't know. And when you have one like that, and it's probably some research situation, like integrate the Wabidoo framework. I've never done anything with a Wabidoo framework. I don't know how long it's going to take. I don't know anything about it. So you can't estimate it. So then what you do is you write a new card. The new card is called a spike. And on the card, you say, estimate the Wabidoo integration. So now this is a card that will go into the deck. And when that card is played by the stakeholders, the task will be to do the estimate. And you can put a number on that card. You can say, yeah, I think that's about a 3. I think the effort involved with estimating the Wabidoo framework is about a 3. Now the stakeholders at the iteration planning meeting will thumb through the deck, and if they really want that Wabidoo framework, they're going to have to do the estimate first. And so then you're going to pull that card out. They're going to pull the card out and say, okay, go ahead and estimate it. And when you're done, you're going to give them a number at the end of the iteration. You're going to give them a number. That's going to go on that other card. Probably have to split the card up into a bunch of little cardlets. And then they can play those cards if they want to. That's called a spike. Take a look at the graphs. In particular, the velocity graph. The velocity graph does not have a slope, or rather the slope is zero, right? It is not rising, or on average, it's not rising or falling. It's roughly staying the same. That is what we would expect. We would expect that the slope of the velocity graph remains relatively constant, because every iteration we get about the same amount of work done. Project managers, however, would like to see it going up. Well, not competent project managers, but new project managers who are a little bit aggressive or ambitious or something. They'd like to see that chart going up. So those project managers might do this. They might say to the team, we've been doing 10 points a week. Let's go for 12. Now, this is a stupid thing to do. It's a stupid thing to do because control theory 101, do not put pressure on your measurement points. Do the measurements without any pressure. If you put pressure on the measurement, you're going to corrupt the whole control. So it violates control theory. It's just a bad idea. You don't want to put pressure on the measurement points, right? But you know that some project managers are going to do that. And when they do that, what do you think the programmers are going to do? Well, the programmers don't want to disappoint the project manager. So subconsciously, this is never intentional, subconsciously, they will begin to shift the estimates down, and eventually they'll be getting 12 points done. And the project manager will believe that they have won. And they'll come back to the team and say, guys, we're doing 12 points. That's great. Now let's go for 15. And a few months later, they'll be doing 15 points. And the project manager, oh, guys, this is great. Let's go for 20. And you know where this is going, right? You come back to them a year later, they'll be doing 1,000,000 points per week because the points are inflating. The points are a currency, right? They're not anchored in anything. They're a currency. They're going to inflate like crazy. How can you stop the inflation? Well, there's a couple of ways. Number one, don't let the project manager put pressure on you like that. Just tell them to get lost. Number two, remember that login card was a 3? You keep that login card around. That is the golden standard card, right? And everybody says, okay, if login is a 3, then these other cards are such and such. That is a way to keep the cards anchored, right? So that's the golden card, the golden standard. By the way, there's nothing wrong with changing the golden standard every once in a while, right? Because nobody remembers what login was like. Right? That was 2 years ago. We don't even know what login was like anymore. So pick another card and say, okay, this one's the 3 now. But you don't do that too often. But do it, in case you need to. It's fine. If you see the slope of the velocity graph going up, you probably have some kind of inflation scenario. What if you see the slope of the velocity graph going down? Well, that's troubling. And that probably means that the developers are making a mess in the code. How do the developers make a mess in the code? They are ignoring the inner red circle. Far too many Scrum sites ignore the inner red circle. They do all of this stuff around the outside, but they don't do the inner red circle, and that makes them make a mess in the code that slows everything down. And your velocity chart will tell you if that's happening. Now, one last thing. When you look at these charts on the wall, how do you know that the data is accurate? How do you know that the developers aren't lying? You know, developers, they're not lying intentionally, but if you ask a developer, hey, you done with that? The developer say, well, yeah. Hey, I mean, they really done? Have they tested it thoroughly? Have they really looked it through? Or they say, yeah, I'm done. So you've got to deal with that kind of issue. How done are you? When you've got this velocity chart, what does that mean? Is that stuff really done, or is there some kind of hidden backlog accumulating? And you can deal with that this way. Writing automated acceptance tests. I told you we might get to this if we had time. Looks like we got a little bit of time. Writing automated acceptance tests. Now, I'm going to show you a picture. See that picture? The hands are the hands of a QA manager in 2008. The document he's holding out for me is the table of contents for his manual test plan. It is not the manual test plan, it is just the table of contents. He has 80,000 manual tests that must be run on his system after every release or before every release. He farms that out to an army of people in India, and it costs him $1 million. It's a fairly large system. Okay? Costs him $1 million every 6 months. He's holding this out to me because the year is 2008. The financial crisis has begun, and he is saying to me, my budget has been cut by 50%. Which half of these tests should I not run? And my answer to him was, well, you can cut the document vertically, horizontally, or depth-wise. You're not going to know if half your system works. That's the bottom line. This is the fate of manual testing. Manual testing is expensive. You have people doing it. And if you have to do it repeatedly, that expense can get to the point where the accountants say, nope, not doing it anymore. And at that point, you're in real trouble. We are programmers. We know how to automate things. So we want to automate. Imagine the traditional quality for schedule. What's the traditional schedule for quality, right? The programmers are working, and then eventually they deliver some kind of load on top of the QA people. And yes, I'm sorry for the disgusting image, but very often it is a disgusting load that gets dumped on the QA people. And the QA people have to do manual testing to try and figure out if that system works. And they are under the most pressure because the developers are always late and the shipment date doesn't change. They have the least flexibility. It's a high stress, tedious job, and it's error prone. Quality cannot be tested in. Our view is that quality is a specification role, not a verification role. We want the QA people to be specifying quality, not verifying quality. And we want them to do that by writing acceptance tests that are automated. We want the business analysts writing the happy path. We want the QA people writing the unhappy path because they're the people who know how to break everything, right? And we want the tests they write to be automated, written in some kind of high-level specification language, not code, but a high-level specification language that allows the tests to be run automatically. We are the programmers. We know how to automate it. All they have to do is supply us with the input data and the expected output data for every different scenario, which they can do on spreadsheets. In fact, there's a whole bunch of tools out there nowadays. There's a ton of tools. There's Fitness, there's Cucumber, there's SpecFlow, there's JBehave, there's Selenium. There's just a whole bunch of tools out there that allow the QA people and business analysts to specify the system in a way that can be easily automated. And then you can push your button. And you push the button, and a few minutes later, a green light lights up that tells you that every test in the system passes, and you know that the system works. And if you have that button, you're going to be like the little mouse who just gets fed every time they push a button. So they push the button without end. When is the best time to write those automated acceptance tests? Well, let me show you when. during each iteration. Of course, we want the automated acceptance tests to come in within each iteration, usually at the midpoint. In fact, I like to see them show up this way. Here's the iteration. Acceptance tests start showing up right away. By the midpoint of the iteration, all of them are done. Not working, they're done. All the acceptance tests have been written. You have the last half of the iteration to get them all passing. If you can't get all of the acceptance tests done by the midpoint, then you've got too many programmers or too few QA people, something like that. You've got to adjust the ratio. These tests are automated. They're written by QA. And now, if you have that, then when you look at the chart on the wall, what it means is that those points passed their acceptance tests. A feature is not done until its acceptance test passes. It's the QA's job to make sure that when the QA tests pass, when the automated acceptance tests pass, it means that the story is done. And so now when the managers look at that chart, those numbers on that chart are done. Those stories on that chart are done. They can believe the numbers. And with that, I will go to the Q&A widget one last time and answer the questions that I see there. SJ says, what is the difference between stories and requirements? A story is a fragment of a requirement written in a way that can be implemented. That's probably the best way to put that. It's a small, generally small, estimatable, valuable bit of behavior that can be written down on an index card and that the stakeholders want. There's no such thing as a single requirement, right? People will write requirement 1, blah, 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 blah. It's actually 80 requirements in there, right? But they say it's requirement 1. The job of the iteration planning meeting is to break that down into a bunch of individual, very small, deployable tasks. Let's see. Somebody said, what's the difference between, got it. What is the relationship between Agile and domain-driven design? Oh, good question. Domain-driven design is the practice that Kent Beck called metaphor. On the circle of life, there is this metaphor thing, and that turned into Eric Evans' domain-driven design. Domain-driven design is the way to define the structure of the system based on the domain language. There's a lot to say about this. I'm not going to give you the whole rundown, but you can get Eric Evans' book and read through that. It's very good book. At least the first half is very approachable. The second half gets a little thick, but the first half is very approachable, very fun book to read, and explains all that very nicely. KT says, is it okay for teams to pick and choose parts of Agile and Scrum they like, or should they try to be more strict? You know, it's up to the team. The team can pick whatever they want. Here's the advice from long experience. Start out with a circle of life, and then you can start removing things if you find you don't need them. Start out with Agile as defined, and then change or remove things as you find you don't need them or you find they need to be changed. But don't try to design your process up front if you've never done that before. Don't look at it and say, well, you know, we don't need that, we don't need that, we don't need that, because you're probably wrong about that. So start with it as it is and then prune it as you move along. Should you be strict about it? No. No, you are going to have to change your process. You are going to have to tune it and modify it for your own needs. Be careful about that, but you are going to have to do that. Ian says, Uncle Bob, it is a known fact that sometimes project meetings can be lengthy and ineffective. How do you recommend to effectively conduct project meetings, scrum meetings, or stand-up meetings for software development teams? Okay. The iteration planning meeting. I have a strict guideline for that. Iteration planning meeting should be about 5% of the total sprint time, the total iteration time. So if you're doing a 1-week sprint, you got 5 days. The iteration planning meeting should be no more than about 5% of that, right? So what is that? 1/10 of that would be about an hour. 5 days, you should be able to plan out 5 days in an hour, maybe an hour and a half, something like that. That's the way I like to lay that out. And how do you keep that meeting under control? You have somebody with the gavel, somebody who says, bangs the gavel on the desk and says, "This is off topic. Let's get back on topic." I have another rule about meetings, by the way. In any meeting I am running, I tell everybody up front, as soon as this meeting gets boring, you may leave. And when people start to leave, you've lost control of the meeting. And you can't point at anybody and say, "Well, you're leaving the meeting." Well, you told me if it was boring, I can leave. It's another way. So you let everybody out of the meeting if it starts to get boring. But the most important thing about meetings is somebody's got to keep control of the damn meeting. Otherwise, they'll just go on forever. Stand-up meetings. They're called stand-up meetings because you stand up. Nobody can sit. Right? Nobody's sitting during a stand-up meeting because that makes it uncomfortable. And then the stand-up meetings got a very strict script, right? Everybody answers 3 questions. What did you do yesterday? What do you plan to do today? What's in your way? No other discussion, no other nonsense. No, well, if Bob does this, then Bill will do that. None of that stuff, right? It's just bang, bang, bang. I did this yesterday, I'm doing this today, and this is in my way. Bang. And then around the circle, bang, bang, bang. That whole thing should be done in 10 minutes, and you should be out of that room. That's really it. Just somebody's got to keep control over the meeting. Otherwise, the meetings go out of control. And if the meetings go out of control, leave them. Walk out. As soon as they're boring, get out of the meeting because all you're doing is burning time. Let's see. TD says, what happens when a 6-point story is half done by the end of the sprint? Yeah, we don't do that. So here's how this works, right? You've got a 6-point story. Hey, okay, that's a big one. How much of it should be done by the midpoint? Well, 3 points should be done. Well, how do you know if 3 points are done? Well, you kind of guess at that, right? But you can guess at it. You think, I'm about half done with it. Okay. Then you come back to it on Thursday. Are you almost done with it? Well, I think there's another hour or 2 to work. Then you come back to it on Friday morning. And on Friday morning, you say, I'm just not going to get it done. And here's the deal, right? If you don't know you're going to get it done, if you cannot sit there and say on Friday morning, yes, this will definitely be done. If you can't say that, then you split the story. On Friday morning, you say, okay, I got to split the story. I can't finish it. And you take the story and split it into 2 stories. And probably the one has got 4 points and the other's got 2 points. And you take that 2-pointer, you put it back in the deck, and you apologize to the stakeholders at the demo meeting, right? We say, yeah, well, we didn't get the whole thing done, but we did get 4 points worth, and here's what we left out. And you'll have to be careful about that. But you try to avoid that as much as you can, which is why we look at it very closely and why they're all so small. Now, what happens really is that by Tuesday, you're looking at that thing and going, oh, this is not 6 points, man. This thing is really 12 points, and you split it early. But if you get caught behind the 8 ball, Friday morning is the deadline. Let's see. SS says, essentially, you're suggesting that if a project is increasingly consuming developers' time with each new feature addition, then bringing more people on board to address the issue might only exacerbate the problem. Yes, in the short term. It seems like a classic catch-22. Well, no, because it only exacerbates the problem in the short term, right? That 1 month or 2 month period where the new people come in, you're going to slow down. There's no No doubt about that. You are going to slow down. But then at the end of that, when those people get smart, the whole team may speed up. Depends on if they're doing a good job. If they're making a mess in there, nothing matters. You can add all the people in the world. If there's a mess in there, nothing is going to speed them up. But if it's a nicely designed system, it's a well-designed system, and you bring people in, yeah, you're going to slow down for a month or two, maybe just 3 weeks, just a short time, and then everybody's going to speed up. What does Agile recommend as a solution to this? Well, there is no Agile solution to it. It's just kind of common sense. Keep everything clean. Expect a slowdown for the first couple of weeks, 3 weeks, 4 weeks, 5 weeks, and then expect a speed up after that, and keep track of it. Let's see. VD says, from my software development consulting experience, we constantly had clients who wanted Agile but fixed scope contracts. Yeah, Agile fixed scope contracts. That's right. I want a circle with 4 corners. Do you have any advice for dealing with clients in this mindset? Yes, I do. I've done this several times. It works out very nicely. There are companies now that use this procedure for all their projects. And that is, you pay by the story point. So everything works exactly the way it was before. You've got stories, you got story points, you put the points on the stories, everything's like that. When you deliver a story of 6 points and the acceptance test pass, you invoice the client for 6 points worth. And you come up with some number, $100 a point or something like that, or $1,000 a point, whatever it is. And you negotiate that all up front so that the client knows, right? And you're going to be paying by the point. So they are going to be paying for delivered business value. They are choosing what cards to play, so they know what they're going to be getting and how much it's going to cost, right? So it's not fixed time, fixed delivery. It's a really interesting kind of share the risk approach, right? They know that they're going to have these points. Some of them aren't defined yet, but they know kind of what they're like. It works out very well. Uncle Bob, IC says, Uncle Bob, why would you say stakeholders don't know what they want? How could we help guide them? This is the everlasting problem of software requirements. The people who want software written do not know at the detailed level what that software should do. They have a gross idea. This is, the guy who comes to you and says, I got this great idea for a new iPhone app. Oh, this new iPhone app is going to be terrific. All we have to do is schedule the behavior of the whammy-doos, and everybody's going to buy this thing, and it's going to be wonderful. And then you start asking them questions. Like, well, what happens if this happens? What happens if that happens? What happens if that, what if you're outside of a network zone? All this stuff, and they have no answer. And their response to that, well, you're the programmer, you figure that out. And it's, no, there's business issues here that you have to address. And this happens in every project. Everybody goes through this. The people who want the software don't want to think about the details. So at some point, you got to either make them think about the details or confront them with the details in a demo. And then in the demo, they look at it and go, oh, yeah, that's kind of what we said we wanted. But now that I see it, it's going to have to be different than that. Let's see. Somebody, SR says, how to manage the fixed cost project when requirements keep changing? Well, if it's a fixed cost, then you stop working after that fixed cost has been delivered. If the customer says it's got to be a fixed cost, okay, well, then it's not going to be a fixed content. Now, if they say, well, it's got to be fixed content and fixed cost and fixed time, well, okay, then you've got the iron cross of project management that you're dealing with, and the project is not going to be delivered that way. No project ever is, right? You never deliver fixed time, fixed content, fixed cost. It just never happens. Right? In a software project, you got to have some flexibility. And honestly, you don't want the clients that demand that. That demand the other way around, or at least I don't. Oh, and that it is the top of the hour, everybody. Okay. It is time to close this down. Thank you all for your attention. I appreciate you hanging with me for so long. And with that, I'm going to hand things back over to Heidi, who will close us out.
Awesome, Uncle Bob. Thank you so very much. And thank you, everyone, for joining us today. Just a reminder, we did record this class, and you can access the recording within 48 hours on the same page where you joined us for class today. Also, on your way out, there will be a brief survey that will pop up on your screen. Please take a moment and complete that survey, as it really, really helps us out. All right, everybody, thank you so much. Have a great day. Goodbye.